Alright, everybody, welcome to the programming tutorial with Temmie. Today we'll be doing Java programming since I've already promised you guys that I'll be making a Java tutorial soon enough. And here it is. So for today's tutorial, I'll be using a software which is called BlueJ for programming in Java. And you can also download it. It's free and it's quite easy to use. Now Java is another object-oriented programming language. So I have divided all the topics and put them together in one single crash course that will help you to learn everything that you need to know about Java basics. So let's get into it and complete Java in one stream. So starting off is the most simplest statement called the print statement, for which there's two methods of printing in Java, which is a very simple two methods, which is system dot out dot println brackets, just like that. Now remember to put semicolon in the end of your JavaScript. So in the previous tutorials when I've showed you doing Python, you don't have to put any semicolons at the end of statements, but in Java you do. Now, when you're creating Java projects, you need to have public class, the name of your file. Then in that, you have to do public static void main string args. Now all of these are keywords, which you cannot instance later on for anything else. So here's one thing, that if you're declaring variables using Java, that variable cannot be named public with the P small. Although it could be named public with the P capital, since Java is also a case-sensitive language just like Python. So if you've seen the Python's crash course, then you would know how it works. So in Java, when you're ending your statement, you need to have semicolon. The other way to do it is system.out.print. Right? Simple two methods. Now the difference between println and print is that println will always print on a new line. Print continues on that same line. So if I were to do this, and I do right now, we have this statement. Now I will be running these statements and you will be seeing it over here on the terminal window of Java. So I will just quickly run the project so you can see. Now before running a project, always remember to compile your project. Right. And if it says there are no syntax errors, then your program will be working just fine. So now let's run this. And I'm hoping you can see the output. Yes, you can. Alright. So if you can see the output, we have hello world in one line and then it goes to the next line and as hello, comma, world. Just what we have written over here. This should print on one line and these two should also print on one line, just in a different line, because this will create a new line as soon as it ends. Right? Very simple. So that was how to print using Java. Then we have some variables, values, and data types. So let's start off. So let me just remove this. Now when declaring a variable, so example, if I do var1, I cannot directly declare that it's 10. I will have to specify what kind of variable it will be. So there is certain kinds of variables. So I will write them down in comments. Now when you write in comments in Java, in Python you use hashtag. In Java, you use double slash. So there is int, char, bool, byte, short, long, float, double, and lastly string. Now remember, string has its S capital. The rest of them have their first letter small. Alright? Is this all? Pretty sure there's nothing else in it. Right, so I think that's it. Right? Yeah. Yeah, okay. So each of these characters are different. So I'll have to create a multi-line comment. Now here's one thing about Java. In Java you can create multi-line comments like this. Now this creates multi-line comments, which is not a which is a feature in Python as well, but it's not very well developed. Many people do not exactly take that feature. In Python you use it like this. In Java you can just simply create something like this to write your multi-line comments, right? So let me just write down what is exactly what. So for integer types, data types, so we have integer type, right, which has int. Let me go from smallest to biggest. So we have byte, short, int, and long, right? Then we have uh, floating type or decimal type, let's say, which is float and double. Now I frequently use double. You can use float. Then we have character type. So that contains a car. So we have char and we have string, right? Now out of these you will realize that string has the first letter capital, the rest don't. Now what is the difference between all of them? Now the integer types can have real numbers, integers, which means negative numbers, and 0. Now real numbers is 1 to infinity, negative numbers is -1 to negative infinity, and 0 is the median between -1 and 1. Alright? Then we have decimals. Decimals is the same as integer, but uh, it also has decimal numbers in it, decimal points in it. Now what is decimals? Decimals is basically when you say 1.5, the 0.5 in it is decimal. And when you convert it to an integer, it will only have 1. And the 0.5 will not exist for integers. Alright? Again, you have explicit and implicit typecasting conversion of these variables. Now that depends on which variable it is. There is a precedence of variables, right? So the biggest variable has the highest precedence and the smallest one has the lowest. So if I were to take a byte and a short, then immediately the next variable will be converted to short instead of byte. And if I were to take a byte and an int, the new variable will be directly converted to int. If I were to take short and long, then the new variable would be long, since long has greater value. Now the greater the value, the more bytes it will take. Now the byte data type will only take 1 byte or 8 bits. Short would take about 2 bytes or 16 bits. Int takes about 4 bytes or 32 bits. Whereas long will take about 8 bytes and 64 bits. Right? It's very simple to understand if you just memorize it. Then in decimals, we have floats and doubles. This is also called floating type if you prefer. Now floats have 32 bits. Do the math and you will realize that that's about 4 bytes. And double is 64 bits. And that is about 8 bytes. Then we have char and we have string. Now on a starting you will say that char has 16 bytes, which is about 16 bits, which is about 2 bytes, and string will have anything more than 16 bits. the more characters your string will have, the more bytes it will have. So for every character, you will add 2 bytes to your string. Now, what is the difference between char and string? We have seen that these basically have higher values of number. So byte will store smaller numbers used for bitwise operations. Short will only have a small range of integers. Integers are used for integers which are more than short integers, and long is used for larger integers. Like for example, if I'm calculating in, let's say, millions or billions or trillions, let's say pentillions, is that a number? It probably is. So if I were to calculate in quadrillions or pentillions, then I'd be using long. If I were to only calculate in 2 or 4, then I'd be using byte. If I were to calculate somewhere between 100, 700, then I'd be using int. Right? Makes a lot of sense, doesn't it? So, for example, if I were to take a phone number, I would be using long. And if I were to only take something like 0 or 1, then I'd be using byte. But most programmers stick to integer, since it is a perfect data type, as it's perfectly long as you need and perfectly short. So it takes about 4 bytes, and it's quite simple actually. Uh, for its simplicity, I think it's not exactly clear why int is more famous between programmers, but it is the most recommended to use. Even I myself will be using int. And for decimal type, I'll be using double, since it has larger it takes about larger number of decimals in it. Float, if you would see, takes smaller decimal numbers. That means it will only have 10 or 20 decimal points in it. Now, how do decimals work? So if I go for example, if I go 0.000001, right? So this could be a float, whereas double would have a few more zeros over here. That's how doubles work with according to float, kind of. It's just an example. That's not exactly how it works. It's an example, all right? Then in char and string, well, that depends technically on how you're using it. I won't be explaining strings in this crash course. We will be skipping over strings in this crash course since we don't need it. And also because is a non-primitive data type, so I'll be only explaining the primitive data types. If you're unsure of what is primitive and non-primitive, then I will tell you non-primitive is any data type that is not included in the main language and it has to be taken from elsewhere, right? Now in Java, even though string is non-primitive, which means basically a class, right? Even though string is non-primitive, we still find it with our main language, but it's non-primitive. It's like the math library, which I'll get to later. I will be explaining the math library, but not now. Later on in a later part of the crash course, alright? 13 minutes have already passed, so let's continue. So now I'll explain how these work. So I have int, let's go for a as the name of the variable, and then we give our value. So this is how you declare a variable in Java. So, this is how you declare a variable. It's not exactly that hard, right? And if you find it hard, then I'm kind of questioning, why do you find it hard? So this is how to initialize a variable. First, you declare the data type, then you declare the name of the variable, followed by an equals to sign, and then the value that you'll be assigning to the variable. Finally, semicolons. Do not forget semicolons. You will get an error instantly, and you can easily debug this error because it's not exactly that hard. And I don't think I'll be teaching any libraries except the math library in this crash course. I will find out some libraries that I can explain later on, right? We'll also have later tutorials for Java, so stay tuned, subscribe, and you will be notified whenever a new tutorial comes out. So this is for integers. Now if I want to do, let's say, a decimal type, so let's go for double and b equals 10.0 d. Now this basically says that it's a double type, right? If this were a float, then we'd go for 10.0 f. So it's not necessary. You do not have to do the d part. So I'll remove it so that you don't get confused. Now, char can only store one character at a time, right? So for example, I can only have a or like 7, something like that in characters. And the only characters that you will need for our crash course today is, I'll tell their ASCII codes. Now, char basically works on ASCII codes. Each character has its own ASCII code, right? So I'll tell you the ASCII codes of the ones that we will be needing in today's crash course. So we have A to Z in capital A to capital Z, which is 65 to 90 in ASCII codes. We have small a to small z, which is 97 to 122 in ASCII codes. And then we have 0 to 9, which is 48 to 57 in ASCII codes. So it's not exactly difficult, and I will be declaring this as G. Alright, let's go for A, capital A. Now, if I were to convert a character to an integer, which is possible, you can convert a character to an integer to a decimal. If you convert a decimal to an integer, then you might get an error, right? It's okay if you convert a integer to character. Now, in the precedence of the larger category, right, we have seen this is basically a small category. If you look a little above into the larger categories, which is character, decimal, and integer, then you will see that the largest precedence is of decimal, right? Yeah. So the largest precedence you will find is of decimal type. So if you take character, it will be converted to decimal. But decimals cannot be converted into character. It might throw an error, but that can also be fixed if you want it to. Integers cannot be converted to decimal. So integers can be converted to decimals, but decimals will not convert to an integer easily. It will throw an error, and that can also again be fixed. So we will also learn how to fix those errors, and that's where typecasting comes in. So we have two types of typecasting. We have implicit and we have explicit. Now, what is the difference between implicit and explicit? Implicit means that it happens on its own without having us to specify that what has to be converted into what. Explicit requires us to specify the conversion. I think my mic is too close. I'll just put it down right. So if I'm converting implicitly, so if I say double x is equal to a plus b. Now this is implicitly converting the integer a to a double x, right? And it's also adding the b value to it. What if it were not this? What if it were c, right? As you can see, there's no syntax error, so this is completely correct. That means the integer a and the character c is being converted into a double, which we have assigned to the variable x, right? So what this does is it will convert this into its ASCII code, which is 65, right? This is 10 on its own, so this will convert to 10.0, and this will be converted into 65.0. Why does the 0.0 added? Because it's a double. Do not forget, it's a double. And then it does 65.0 plus 10.0, adds them up, which is 75.0, and gives it to the value of x. Now if I compile this and run it just to prove to you that it works just fine, then you will see it will work exactly how I told. Oh wait, I forgot to print this. So let me just quickly print this out. Right. So now I'm printing this. I'll run the program, and as you can see, it says 75.0. I will have to clear the screen so it becomes more clear. Right, there we go. 75.0, as I said. So some things you will have to understand just by reading the code. Reading the code is not hard at all, right? So this, what you have seen, is implicit typecasting. Now I will show you explicit. So let's create a int y is equal to b plus c. Now c would be converted implicitly into an integer. Doubles cannot do that. So now if you see, oh wait, just a second. Now if you see, this throws an error found in class. If you see, possible lossy conversion from double to int. This is the error that will throw back to you. It is very easily fixable if you use explicit typecasting. So how do you do this? You will do in brackets int, just like how I did it. And now when you compile this, would you look at that? It works just fine. Now this will remove the 0.0 from it and convert it into an integer. So if this were, let's say, 10.5, so it will only take 10. And we know char C will turn into 65, as that is its decimal value. Not 65.0, because this is not converting to double, it's converting to an integer. So it will not convert to 65.0, only 65. Plus 10. That is 75. Not 0.0, just 75. So I feel I should clear the screen before I run this again. And let's run it. Just 75, not 0. I told you. So that is how implicit and explicit typecasting works. Everybody understood? Great. Who am I even talking to? There's nobody in the stream. I'm hoping this blows up soon. Alright. So that was typecasting. I also told you the precedence and hierarchy, right? Here's one thing. Implicit typecasting is also called coercion. Coercion. I don't think there's more to it now. So I think that was it for variables, which is values and data types that you needed to know. Now it's time we get to operators. This might end quicker than you know, because since I have already explained for Python, it will be easier to explain Java for the old audience that has came back. For the new audience, well, don't worry, I'm still here. So now I'll be teaching operators. So we have arithmetical operators to start with, which consists of the multiplication. Now since we cannot use x, while programming, for the newbies, we do not use x for multiplication and programming. You know why is that? That is because x could be a variable. What if I could declare a variable called int x? So if I do int x equals x into x, right? Or let's say y equals y x y, and then we have another integer which is x, right? That would make no sense. No sense at all. That would confuse your PC. That would confuse the core of what is going on, because it'll be confused whether it is a multiplication symbol or whether it is a variable. So that is why now you cannot name a variable the star symbol. There's also some rules for naming variables in Java that you will have to follow, and it's for most programming languages, not just Java, for most programming languages, which is very um very normal. If that weren't to be, then naming variables could have been making it harder and less understandable for the PC to understand the variable, right? So, just a second. What's going on here? No. Uh, Leave from streaming. God damn it. Right, I'm back. So, where was I? Still no viewers. I was teaching the rules for naming variables in Java, right? Right? Yeah. Right. So you cannot start off, but you cannot. First of all, you cannot give an empty name. Secondly, it cannot start off like this. So if I were to do $x, no, it cannot do that. You cannot even have dollar signs, right? It cannot be a keyword. So if I were to name it like this, or if I were to give it some other name like this, I cannot name it that. That is wrong on so many levels. See, illegal sort of expression. Uh, that is the output it will give you. So if I were to do $x equals 5, right, and I do this now, it'll now right now don't show any errors, but later on you will face a lot of errors, right? So your names must begin with a letter. Although you can have dollars and underscores in the middle of your naming. So if I do S underscore P, right? Uh, I can name it like that. That's fine. But I cannot start with an underscore. Well, you will it's not wrong to it's not wrong to start with dollars, but it kind of makes it confusing, so we will not be using it in this tutorial, since in later programming you might face difficulties. So we'll just be avoiding starting with dollars or with underscores, although you can do that, right? It's most recommended that you start with letters. You cannot start with numbers while naming your variable. That throws back a little error. It'll give you this error that semicolon is expected, right? So you don't want to start off with numbers, and I don't think you can have, yeah, you cannot have dots as well at the starting. So yeah, you start off with letters. One, you start off with letters. Two, this is not equal to this, right? That's two. Also, where did I cannot see where I'm typing, to be honest, because for some reason that thing that you see while typing is gone on the screen. Why? Why? Come back. Right, now this is what we use for division, because if you look at your keyboard, then you do not have a division symbol on your keyboard. Nowhere. Right? For addition, since we do have a plus symbol, and we do not start naming variables with that, you can use it. It's fine. So this is addition. And we have subtraction. Again, it's on your keyboard, and you do not start names with this. So, oh god. That was that. So that was arithmetic operators that you will see in Java. There's one more operator. I'll show that as well, I think, which is this. Now this is called the modulus. Now this works like the division, but it's different from division. How so? Now the division will give you the quotient after performing a division process or division equation. The modulus, on the other hand, gives off the remainder. And in fact, the modulus is very, very important while programming with any programming language. Right? So this is the modulus. Then we have assignment operators. That is only the equals to sign, nothing else. That is the only assignment operator that you will see. It basically is used to give values to a variable. Very simple. Next we have unary. Do you know what unary operators are? Well, your minus and plus are arithmetic as well as unary, right? Another arithmetic operator that I just remembered is brackets. And just like variables, these arithmetical operators also have a hierarchy in which the greatest precedence is given to the brackets. Right? Then comes modulus and division and multiplication. Right? Then comes addition and subtraction. And finally comes assignment. In unary we got minus plus, plus plus, and minus minus. I'll explain plus plus and minus minus later on. So currently we'll not focus on that. Right? Right, so that was that. We also have right, your arithmetical operators can also be called binary operators. So basically there are two types of arithmetical operators, which is one is unary, second is binary. So minus and plus are both unary as well as binary. There's a very complicated division of these operators in Java, right? So leaving that, now we have ternary operators. Wait, oh no. Right, so where was I? Right, ternary. Now ternary is basically conditional statements. I will teach that later on in this tutorial. We'll not get to ternary operators yet, right? So leaving that, next we have relational. Now that is again just like Python. We have equal to, we have less than equal to, we have greater than equal to, we have greater than, we have less than, and we have not equals to. So these are um, all the relational operators. Now, what relational operators do is that they check for two values. Let's say we have like a and b, and it checks whether a certain condition between a and b is true or false. So if a is equal to b, it will return true, and it'll do a certain set of things related to it. And if it's not, then returns false. And that will again be used in conditional statements. Uh, so basic along with ternary operators, and we got logical operators. Again, very important, like all the others. So we have the and, which is called the and in short. We have this one, which is called the or, and we have this one, which is the not. So we have logical and, logical or, and logical not. We have some more like XOR, which is basically exclusive OR operators and stuff, but we will not be doing that in the beginner course. Maybe in the intermediate course we could do that. So basically the difference between OR and exclusive OR is that exclusive OR only requires one statement to be true, or requires either one of these statements to be true, right? So like if I have two statements, this is basically like used by using relations. It could be something like A is equal to B and A is, or maybe something more like A is less than or equal to B, or A is greater than or equal to B, right? So it could be something like that, or A is equal to B, or A is less than or equal to B, something like that, or maybe A is not equal to B, right? So I will teach how to do that later, right? We have some more operators like the dot, which is literally the dot, and new, which is literally new. So these ones are keywords as well. All of these operators are keyword actually, right? So that was that for operators. These are all the kinds of operators you will see. So now I'll explain how they work, right? So in my own words, I'll say for arithmetical, let's start with some integer x and y. So this is how you create the integers. Now when you are writing it later on, you don't have to then write like this again. Right, so I'll give x the value of 5 and y the value of 8. Now once you declare it like this, you don't have to write int x again and again and again. So you can only use it once. Even if you just do int x equals 5, then if you want to change the value of x, you don't have to write int ever again. It's only once, just to declare what kind of variable int will be, x will be. So if I do x equals 5, and then I can do x plus plus. Now what does this do? This will basically increment the value of x, and if I do let's say minus minus x, same thing, it decrements the value of x now. Of course, instead of writing it like this, I could also write it like this, plus plus x, or x minus minus. They work just the same, but they will make different sense when you use it in arithmetical statements or equations. So if I were to do, I'll head over here. If I do int z is equal to plus plus x minus, or let's say multiplied by y minus minus plus y. Right? Now what this does is, it first increments the value of x, then multiplies it with y, So 6 into 8 would be 48. Yeah, yeah, it's 48. Okay, it will be 48, and then when I do minus minus, it decrements the value of y to 7, and then plus y. So 48 plus 7 this time. That is 55. So z gets the value of 55. There's also another type of operators which is called the shorthand operators. I think I'll be using it very often in this tutorial. So shorthand is plus equals to, minus equal to, into equal to, and slash equals to. Now these basically work in such a way that this will add it. So if I do z plus equal to, right? Now what this does is, this is a shorthand operator over here, right? Now what this will basically do is, what happened? Oh, right. You can only use it like this, right? So you have to declare the variable first, then only you can use the plus equal to. Since when you declare it, right, if you give int z, then it will automatically get the value of 0, right? Now if we do this, it adds to the value of 0 as plus x into y minus minus plus y. So this will basically add 55 to z, right? It's very simple actually. So that is kind of what will happen. This is how to write an arithmetic equation. Now when I'm explaining conditional statements, I will also be explaining the relational and logical operators. I don't think I'll be explaining the dot anytime soon. Oh wait, I will be. I will be in mathematical statements, which is not too far from now. Not too far. Let me just take a check on the chat real quick. Ah, there we go. Right? So, continuing. So this is how it works. We have x and y. So x is 5, y is 8, and then we perform this arithmetical statement. And now, as I said, it will turn out to be 55. I have already done the calculation. You can kind of predict the calculation just by looking at it, right? And then now let's print out z. And if I run the program, is everything visible? Right, it is. Great. So now if I print out the x, so let me just run the program, and as you can see, 55. I should have cleared the screen. As you can see, we got 55, which is exactly what we predicted. So that was it for variables, right? Now getting back, we have now seen how these arithmetical operators will work. We have seen shorthand operators, we have seen unary operators, and assignment operator in one go. Great. Should we now get to mathematical libraries? So if you want to use mathematical libraries, then you do not have to import anything like Python. In Python, you will have to import NumPy or math. In Java, it is intended with the main programming language, but it's still a different class. So if you want to use mathematical libraries, then, so I'll just create a system out println statement here, and over here in this, I will put math dot. Now the dot operator will basically call out for a function in a class. See, so math over here is a class and will call out its function. So I will go through each and every function of the math class, right? Okay, that kind of is bit of a catch. So I'll go through each and every single function of the math class now. Starting off with math.min. Now, what does math.min do? It takes two parameters, which is one number, two number. Now, these numbers could be even like this. So it could be 10.9 and 20.7. So it could be either decimal numbers or integer numbers, right? If you put integers inside, it will return an integer. If you put decimals, it will return decimals, right? So that kind of depends on. Thanks, kid. Right. So where was I? Yeah. So it'll basically take two values and see which is the smallest value between the two of them. If this is the smallest value, then it will print out this. If it's not, then it will print out this. So if I run it for you, just so that you can have a better understanding, right? You will see it prints 10.9, which is a smaller value over here. Perfect, right? And now the second one is math.max, which does the exact opposite, and I'm pretty sure it does not require me to run this, but I'll still do it anyways. Right? So, if I run this now, we will get 20.7. Perfect. Two viewers, great. We get 20.7, that is great. So that is exactly how we programmed it. Now, moving on to the next function, we have match.pow. Now, I will remove this so it doesn't get very complicated and it's easy for me to explain. Now, what does match.pow do? If you have ever heard of indices, right? If you ever heard of square or cubes, then you will know how match.pow will work. It will take one number and then it will take its power. So let's go for 2. It's a very simple number, and everybody knows its powers very well. So the third power of 2, which is the cube of 2, is 8. We all know that. So this will be the base number, and this will be the power of the number. That's the second parameter, right? So when I print this along with this, it will give us 8.0. Remember, match.pow always sends back decimals, whether you put integers or whether you put whatever. It will always send back decimals, alright? So now we have seen that, let's go for square root, SQRT. Now, it doesn't take two values, it only takes one value. So if you go for square root of 4, it is exactly what it says. It gives you the square root back. So now we will go ahead and run this so you can understand. And it gives us back 2.0. Again, this also gives you back decimals. Whether you put integer or whether you put decimals, it will always throw back decimals. Since the square root of 4 is 2.0, we will get back 2.0. Next we have cube root. I will not be printing this one. It's very simple. If you understood the pow part, then you will definitely understand what this does as well. The cube root part will simply find the cube of a number. So the cube of 8, this will throw us back again decimals. Whether you put integers, whether you put float, it will always throw you back 2.0 since that is the cube of 8, right? So next function will be log, right? Now let's say log, basically it uses logarithms, right? So it just returns you logarithmic value, which means you put a value in it, right? And it will give you back its natural log, which is to the base of 10, and then the number could be anything, right? Anything you wish. And there goes my viewers. So if I put 6.25, it will give us back 1.8325, something like that, I think, right? So that is how log works. Now abs stands for absolute. not the abs from gym. Absolute. So absolute will basically, if I put in -8, it will throw back to us +8. So it gets rid of the minus part in it, right? Now, this is actually useful since if you're doing square rooting, then it doesn't never takes uh minus values. It never takes negative values. It only and only will take positive values, since negative number is an imaginary value. Square root of a negative number is an imaginary value, so that is why it will throw you back NaN, which means not a number, right? So there goes my viewers. Great. I know. Again. So that is the use of absolute. Then we have round. Right? Now, what does round do? If you have ever rounded numbers in mathematics, you will know how it will work. So basically, if you don't know how rounding works, then imagine you have a number 4.2. Now, if you round this out, it will give you 4.0. If it were anything above 4.4, so let's say if it were 4.5, then it goes directly from 4 to 5.0. So basically gets rid of the decimals to give out a simple number to make things easier to understand. It's usually used for currencies. Like, for example, if you do not have smaller currencies, right? If you don't have 0.5 cents, then that rounds off to 1 cent instead, right? If you don't have 0.4 cents, then it'll round out to 0 cents. Makes things free, I guess. So 4.5 would turn 5.0, 4.7 would turn 5.0, 4.9 would turn 5.0, but 4.1, 4.2, 4.3, and 4.4 would turn into 4.0. Alright? Very simple, isn't it? See? Java is a very simple language if you try to understand it. um yeah, so that's that. Then we have mat.seal. What does seal mean? Seal means ceiling. So it basically goes ahead in the number line. If you've ever seen a number line, then we have 1, we have 2, 3, 4, 5, 6, and then we have 0, right? We have 0, we have -1, -2, -3, and so on, right? Let's go for -4 as well, right? So this is how it works. So we have negative numbers, we have positive numbers, and we have 0. So that's how integers will work, right? Now, if you've ever seen a number line, and then there comes in between randomly just 3 point, let's say 3.6. Where will this go? If you want to take it ahead of the number line, that will be called going for sealed. So if I do math.seal 3.6, then it goes ahead in the number line and reaches to 4, right? And it throws us back 4. But this works otherwise. If I do -3.6, now it will go ahead on the number line again, right? To the right side of the number line and goes to -3. And the opposite of this is match.floor. So if I do match.floor -3.6, then it'll go to the left side of the number line, to the nearest without decimal value, which is -4. And if I do it on the positive side, if I do +3.6, then it goes to the left side to the nearest not non-decimal number, which is 3. So that's how it works, right? Very simple. Floor and seal. And next we have math.random. Now math.random is a bit of its own function. It's quite messy. I don't really like math.random on its own. So basically, math.random would take any random decimal number, which is always using doubles. Math.random always uses doubles and will print out random numbers between 0 and 1. Of course, you can multiply it by 10 or by 100 or 1000 to get any number between 0 to 1000 instead. And you could convert it to an integer to remove the decimals in it as well. Right, so that is kind of like the modifications you can make with the random function to get better values for different reasons, right? We also have some trigonometrical functions like cos, sine, tan. So we have like math dot cos, math dot 2 radians, right? So you can kind of use the Java documentation to understand that, or you could join my Discord server where I will always be there to help you understand it better. But I can't do it on this crash course since it's already been too long since this crash course has been running, and we need to finish it quickly. So I will not be explaining all the functions since there are only a few functions left, which is 2 degrees, 2 radians, and sine cos tan. So that's all trigonometrical functions. Now we'll be doing something better. Now I will be teaching you. So I'll just get rid of what we have learned in these operators. Right? We have done this, we have done this, and we have done the dot operator. So now we'll be learning the new operator using a library called scanner. Now this will only come if you write the word import java.util.start. This basically calls for the Java, then it goes to the library util, which is the utilities library, and then it calls for everything that is in this library, every function, every method. And we go scanner sc equals new scanner system.in. Memorize this one, it's very important. Now scanner basically, if you were to take inputs, this is what will help you. In Python we can just simply write a equals input this, right, like that. In Java it works somewhat differently, so you'll have to do int a equals sc dot next int. Now I will explain what I've written here. So we called for scanner, the scanner class, and we declared it as a form of variable sc, and gave it the assign, and then we used the assignment operator to assign it the value of a new class scanner, which gets system in as one of its parameters. Right? Right? Very simple. Very simple. So this is basically used to call out a new class. So now we have learned how new works. So let's remove it from the list. And then we take a as a next int, which means always make sure. If a was a double, I would be writing next double. If a was a char, I would do next dot char at0. I'll explain how this works too, right? But currently, let's start off with next int. And then if we do system.out.println number plus a, right? Now what do we see? It'll take the input of a and it'll print out a, right? So if I run this just to show you how it works, right? Let's do this real quick. Now it'll ask us to type input and press enter to send to the program. So now we have to type any input. So let's go for 20. And when I press enter, it takes this 20 as an input and then prints it out. Number is 20. Now, why does Java use next int, next double, and everything differently, unlike Python, which just takes input? That is to make things more easier for the programmer. Since in Python, sometimes people get confused whether they have to use this data type or that data type. Java understands that the program is already pretty clear. So, one thing in Python is that you might have to debug a bit to understand, since it takes every input as a string itself. Then you have to convert it to an int uh, separately, or a float separately, or anything else, boolean or anything separately. You cannot do it on, it does not happen on its own. So that increases the workload of the programmer himself. To decrease that workload, Java has created the nextInt function instead, right? So it's quite nice. Uh, Now next let's move on to next double, which is the same thing as nextInt. So just how I showed nextInt, next double will work. Next char 80. I need to pay more attention to this one. Char 80 will be useful in the later methods. So let's make this a char instead, right? Now char a is sc dot next dot char 80. What this does is it calls for the sc. Then next has its own method, char 80. Now what does char 80 do? Basically we can type any string we want. So if we go for something like ABC, right? So it will only read A from it. If this were char 81, then it will be reading only B from it, right? If it were 2, then it would be reading only C. But we usually do char 80 since we need to read the first letter most of the times. But as per your convenience, you can set it to whatever you like, right? So now let's run this. Now we will have to not put a number, but instead we'll have to put a char inside. So let's go for H. And as you can see, I forgot to change the output. You can convert this to character instead, as per your need, right? You can just convert to as per your need. It's not really necessary to always keep it. I'm just giving an example, alright? So that was that. Now for strings, it's a bit different. You don't have to write all this. You can just finish it at next. But if you still want to do something, you could do next line. Right? You could do next line this time. So that was that. I don't think there's a lot more to taking inputs in Java. So that clears inputting in Java. Now we will get to conditional statements, right? So, conditional statements in Java. There is, I think there are two types of conditional statements. We have if, else, if, else, right? And you can also nest this. So let's try creating a little program. Now, let's say int a is equal to 5, int b is equal to 10. If a equals 5, a is less than or equal to b. Let's do this. Right. So I'll just quickly write this out and then I'll explain it. I'll also show what it does. Now, simple logic. If A is equal to B, A is equal to B. Otherwise, it'll be less than B or it'll be greater than B. It cannot be equal to or greater than or less than equal to or greater than equal to. That's not possible since we've already checked that it's not equal, right? So now we are seeing the relational statements at its work. So we are checking if A is equal to B, then we'll run a certain number of statements. If that isn't, but if it's not true, what if it's not true? This will only happen if this is true. If it's false, then it goes to the next one. Then just skip this whole part and goes ahead. Or else, if A is less than B, then it will do this. But that is only if it's true. If it's not true, again, it goes ahead. Skips this whole thing and it goes ahead. Or else, then it'll check for the last possible outcome. Or like if these two aren't true, then it will directly print this. It does not check anything, it just prints it out as it is. But if either of these is true, then this will not print, right? So that is if statements. Alright, now I can see this thing. Great. So if I run this, I'll just run it just to show. We can already see that A is 5 and B is 10. So, of course, we'll get A is less than B, right? A is less than B. What if I were to change it around a bit? What if I were to do something more like A is 10 and B is also 10? Then we will get a different output. Now we get something more like A is equal to B, right? Now what if both of these couldn't be true? What if it was something like 15? Now if I run this, A is greater than B. Very simple to understand, very simple to apply. Not a lot of complications at all. No complications actually. Right? So we've seen how if-else-if statements work. You can also nest them, which means you could put an if statement inside an if statement, right? And see if it works or not. Now, here's one thing that will help you out a bit with programming, although I don't usually do it. You could remove the brackets. It's not really necessary. That is only and only solely if there is one statement ahead of it. If there is more than one statement, then the second statement will not get executed at all. The second statement will get skipped or will happen and then the next set of statements happen. So only if there is one statement ahead of it, you can skip this, or else you will have to put up the brackets. Right, currently, as you can see, I can do this. Why? Because there's nothing ahead of it. This is just one statement as it is. Right? Simple. Very nice. Very beautiful. Perfect. So that was kind of it. That was it for conditional statements. There is one more conditional statement, although that I do want to show along with this, and that is the switch cases. Ever heard of switch casing? Now, switch cases work a bit differently. Instead of using if and else if, switch cases are very different from your if else if. If else if can check for ranges. It can check ranges and ranges of things using the logical and, right? So I'll also show how the logical and works. So I'll show the logical or actually, and the rest of the logical statements work just the same way. So if I were to write A or A is greater than B, right? Of course, you'll have to open the brackets over here to put this up as one statement, right? Now you are saying if A is less than B or A is greater than B, then we will print A is less than or greater to B, right? We can already see that A is greater to B, but if we do this, it will print if that it's less than or equal to less than or greater to B. So that is kind of how it will work. So it's not really difficult. That's just exactly how logical and relational operators work. So we have seen how that works too. So now um, let's get to switch cases. Now, if statements can check between ranges and it can check every single data type that is to exist. But there is switch case, which is a sort of substitute to make things easier as compared to if statements, right? It's kind of like working as a substitute to if statements, and it can only check int and char, nothing else. Only int and char, not even decimals, just int and char. So how do you declare a switch? So we do switch the name of the variable, right? So A, of course you cannot put multiple variables inside because it does not check ranges. And then you write case, let's say if I want 5. Then we do system.out.println A is 5. Let's close this. Right, now just copy this and I will paste it twice. Again, this is only for understanding, mere understanding, nothing serious. And of course you cannot copy these two, right? So I have to go for 10 and 15. So let me just make some changes here as well. So what you see here is it checks for different cases for a value you have given to the cases. So if I were to say that if I say that A is 15, so we'll go for switch A. So it checks, is 8 5? No, it's not. Is it 10? Nah. Is it 15? Yeah, it's 15. So then it will run the next set of statements that come ahead of it. And there's also this one that you can write, default. So system out println A is something else, right? Again, this is just an example, only an example, right? Wow, stream is not going well. Okay, so it will check, is A 5? No. Is it 15? No. Is it 10? No. Is it 15? Yes, it's 15. So we'll run the statement and then it will end. That will end only if I use a jump statement. Now, what is a jump statement? There are 2 jump statements in total in Python as well as Java, right? So where I know. That is break and continue. Now, if you do not want to go through fall through, what is fall through? I will show you actually. Instead of explaining it, I will show you what is fall through. It's sort of an error which does not exactly show up on screen, and it's not exactly an error. You can even use it in some programs if it's required, although I really don't understand its requirements. As you can see, we set A to 5, right? Didn't we? A is 5 here. But this decides to print everything. That is because it's never ending. This is called fall through. When all these statements ahead of it, which are not supposed to print, prints. That is because this falls into all these statements. Right? So how do you avoid fall through? Is by breaking each and every single one of them by using this break keyword. Right? Now for default, you will not have to use break because it's the last statement. There's nothing ahead of it. You don't have to put break in front of default, right? So break is not compulsory. Do not get it mixed up. Break is not compulsory. It is just to avoid fall through. Never say that break is compulsory. That is wrong, right? So now let's do this and let's go ahead and run the project. Now we get A as 5. Do not ignore the rest of this. This is from earlier, which did not get clear. A is 5, you can see, right? So it works perfectly. Now, if I were to say that A should be 15, which is where we started, and then I go ahead and run this. Running this is a very tedious process. So we get A is 15. Perfect. No fall through, nothing. It's just a quicker, more easier way of writing things without having to write too many brackets, too many statements. No, it's make things somewhat better, somewhat simpler for programmers. Especially if you are making um, a menu-driven program. I'll teach you what menu-driven programs are later on, or maybe on my Discord server. If you're making a menu-driven program, then this just makes things a lot more easier, right? So, iterative constructs. In the next tutorial, I will also be doing a few questions that I find online to do with you all for revision of what we have did today, right? Now let's do the iterative constructs or the loops that there are in Java. Uh, just like most programming languages, again, there's only while loop, for loop, but there is one extra which is called do while loop. Now, do while is an exit controlled loop, whereas while and for are entry controlled loops. What is the difference between entry controlled and exit controlled loops? Entry controlled is uh, when the condition is checked first, and exit controlled is when the condition is checked at the end after writing all the statements. I'll show you how so. So if I do while a is greater than 5, print, wait, system out println, and I put a comma here. A plus A. Let's just go for A. And now, one thing about while is that you will always have to increment or decrement the values, or else, even though it does not throw an error in the compiler, but it will start up an infinite loop. It will be unfixed, right? It will be unfixed, which means it will run an unknown number of iterations. What is an iteration? Iteration is basically every time you run a statement, it's called an iteration. So you will always have to increment or decrement the value that you're checking. And if your value does not correlate with the main program itself, then there goes. Your thing might crash, and we do not want that to happen, right? So let's just quickly decrement our value. Since we're checking backwards, it goes from 15 to 5, right? So to avoid any errors. And now if I run this real quick, you can see 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, and it stops, right? Very perfect, very nice. So this is how while loops work. You write while, then here goes your condition. I'll actually write it inside condition. Oh wait, I'm not supposed to write it inside here. Right, condition, statements, increment slash decrement, right? So this is how while loops work. Memorize this, it's very important. Now let's go to something else, which is called for loops. I think I should remove these two now. For, let's start with int I is equal to 1. I is less than or equal to 5. I plus plus. Alright, I'll give you 5 seconds. Can you guess what the increment and decrement? What is this plus plus also called? I'll give you 5 seconds to guess. 1, 2, 3, 4, and 5. If you guessed it is unary operator, then you're completely correct. It is a unary operator. Perfect. So I guess you do remember what you did back. And if you don't remember, please go back and rewatch what operators are again. Alright, let's continue now. So let's go system.out.println and then I. So what have we done here? We declared the variable I inside the for loop. The difference between while loops and for loops is that in while loops you will have to declare your variable outside of the loop. Whereas in for loops you can do it where your loop is beginning. And then you put the condition and then you put your increment or decrement again inside the for, right? So you don't have to put it here again, or that might skip a few iterations for you, right? And then if you do this, it will print from 1 to 5. So it goes 1, 2, 3, 4, 5, right? I think I should clear the terminal before I do this once more. Things seem to get a bit laggy right now. Right? 1, 2, 3, 4, 5. Exactly how we predicted. Perfect. Perfect. So that is how for loops work. In a few, not too long later now, I will also teach you nested for loops, which is very, very, very important. I'll also be doing some questions related to nested for loops, which I find online, which is going to be just patterns. We'll be drawing some patterns in a later tutorial, right? So subscribe and stay tuned to see the later tutorial, right? Now we have, again, jump statements. You can even do, you can even put something like if I is equal to 4. And then you could kind of end the loop here by putting in a jump statement break. Now this basically cancels out the loop and goes to the statement ahead of it, right? This doesn't end the program. But there is one more way in which you could basically end the program as it is system.exit 0. Don't forget to put the 0 in it. Now this will completely just end the program as it is, and nothing happens after that. No ahead statements will execute. The program just ends. That's how jump statements work. I don't have to run this again, right? Because I'm pretty sure you kind of understood what would happen. And if you don't, then go ahead and try it for yourself. It will be, I will appreciate that since it helps you practice. Then we have the do while loop. So, do while. So in do while loop, we first declare the statements that you will be having. So let's say system.out.println I, and let's declare our int I equals 1, and then while I is less than or equal to 5, right? You can put other statements out here, like system out println sequence. Right. Now what this will do is it will check. Oop, what happened? All right. So this is an exit control loop uh, where the condition is checked last. Just a minute. Right. So I was saying, this is an exit control loop where the condition is checked at the end, right? Whereas in entry control loops, the condition is checked first. So let's run this, and you will see that it goes from 1 to 5 after printing the line sequence. Got smoother somehow. Oh. Right. Uh, there, that created some lag. Thank you. Ugh, lag. Right. Don't forget to increment or decrement depending on what you need. And did I clear the right? So it goes sequence and then it prints. Oh great. It goes sequence and it prints 1 to 5. Right, just like how I told you. So that was do while loop. What else do we have in here? Wait, let me remember. Uh, right. Another thing. Another conditional statement is ternary operations. How do you do ternary operations? It's basically to reduce the amount of tasks that you have to do. So you could kind of use it in here as well. So I could do system.println I is equal to I is less than 5, and I put a question mark. And now there will be two things that you could have done here, and that is separated by this. So this basically acts as an else, and there's only two possible things you can do. So there'll be like if else. There's no if else if. It's just if and else, right? So if I is less than 5, uh, let's just do that. I is less than 5, or else I is not less than 5. Right? Now, since we can see and we know that I is not less than 5, we will understand that it will print I. So I is less than 5. We know it will print I is less than 5. So let's just do it anyway. I is less than 5. So that's how ternary operators work. It's just to um, reduce the amount of tasks that you'll have to do. It's just to make things shorter and easier to write. It's very useful actually, right? So that was iterative constructs, ternary operators, conditional statements. What else is there? Right, nested for loops. So let's do nested for looping. I will be showing a pattern to you to explain nested for loops. Right. Now, of course, if you can nest your if statements, you can nest anything almost in programming. That is one thing about programming that you should know. Also, you can do this. You can do this in for loops. So basically, it will take I to the value of 5, and then if you do system out println 5 over here, then it prints the value of I. This is 5, right? So if I do system out println I over here, it will print 5 on the output. Right, so but we don't want that. We're showing nested for loops. So if I do for int j is equal to 1, j else before it's equal to 5, j plus plus. Now try thinking of this Now try going more intellectual, right? On a more higher level. And think of this as rows and this as columns. So now I will put a system dot out dot print ln. Of course, you can leave them blank. System dot out dot print j. What would this do? Think about it. I will give you a moment, and you just have to close your eyes and imagine what this would do. Meanwhile, I will write it down so you will also understand. This is what it does. It prints 1 to 5 times, right? I'm pretty sure it does that, right? Hmm. So let me run this to show you how it will work. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 4, just how I showed it. I should also have added the spaces here, just like this, right? To make it exactly like that. There you go. Looks exactly like that, doesn't it? Compare it, compare it. We got this over here, we got this over here. Looks just the same, except it's a little darker tone, but that's not exactly the point here. Right? Exactly the same. Works just the same way. Um, oh, nice. Thank you, thank you. Right. So this is this. Another thing that you could do is you could do this. What would this do? Think of it like rows and columns again. This is what it gets like. Nice. So basically makes sort of like a stair design. A little pattern again. So most nested for loops this are used to create patterns at a beginner level I'm talking about, or they could be used for many purposes. I'm talking at a beginner rate where you are doing a basics crash course. So at this time you would only require patterns. There's no huge use of it. You can also create reverse patterns by doing it something more like this. Take this, so I could just copy this out and put j to 4, j is greater than equal to I, j minus minus, it should be 5, right? So now this will like create a reverse pattern, and trust me, this will look real cool. This will look really cool, trust me. Oh yeah, that's cool. It's kind of brain wrecking. 1 5, 1 5 2. Yeah, it's really nice. I like this. All right. So just think of it as rows and columns, or like however you want it. In my case, I'm only teaching you how to create rows and columns. Very simple, basic things that you need to know for Java programming at this time, right? And there we go. We have now done nested for loops. We have done variable initialization, we have done iterative constructs, we have done conditional statements, mathematical libraries, inputs, operators, values, data types, and uh, yeah, that's it. That's the entire Java programming language. Oh yeah, and printing statements. So there we go. That was the end of Java programming language, everything that you needed to know to understand Java. And stay tuned, subscribe and stay tuned to learn more of Java. I'll be posting more tutorials related to this with some question solving, as well as some libraries and methods that you might need to help you master Java and become a professional Java programmer. So thanks for watching. Subscribe. Bye. Now tell me what would be the output of this. No, the output would not be it printing it out. It would be you going forward and subscribing. So thank you. Bye. It was a great time.